Welcome back to day 17 of LeetCode grind. Solve or go home. 30 minutes solve or go home. Alright. What we got? What we got? Combination sum 4. Alright, given an array of distinct integer nums and a target integer target, return the number of possible combinations that add up to target. The answer is guaranteed to fit in a 32-bit integer. Okay. Does this condition even matter to the question?
What condition?
The answer is guaranteed to fit in a 32-bit.
Oh no, then you won't time out or have some weird shit.
Okay.
They only ask you things that are that don't have to deal with robust.
Okay, so it says nums is 1, 2, 3, target is 4. They're saying how many different combinations within this array that you can make equal to 4?
Correct.
And it basically it could be any element with any other element, including itself.
Yes, exactly.
Okay. So it's just like it's a permutation thing. It's just number of combinations, right? Kind of thing.
Right. I guess yeah. So you'll need some counting thing for the combinations, and then you also need some way to, I guess, efficiently calculate what can make this target.
All right, because because you can combination with itself, it could be endless. If it was just a typical
No, it cannot be endless.
well,
It cannot be endless.
it won't. I'm not saying like endless, but like it's gonna be inefficient. But then, like in the typical scope of the when you do combinations, typically, because you don't need DP for combinations, it's just a DFS. I mean, a BFS.
Sure.
But for this one, because it could keep chaining on itself, then that way, I guess it requires more like efficiency. I guess I'm not sure.
Right.
Okay, so in that scenario, okay. Okay, so I think basic steps first off is if you're doing DP, you need a memorization. So I think for the memorization, you're looking for.
Well, hang on. Before we jump into DP, do you already have some idea of why we want to do DP?
Well, it's because you're gonna be using recursion, and if you're doing that, if it's
Well, how will we use recursions?
basically what my thinking was is given the current number, the current target left to do, you can choose one of these integers within the array to keep going with. So basically, you're branching off paths until you hit 0 on the target, and you're just subtracting whatever you're choosing from the array from the target. And then you do that and try to build out every single combination possible using that kind of recursion.
Okay.
Yeah, so say you're starting with 1, right? So your target is now 3 because you already have 1. And then now you say, how do I build 3 with 1, 2, and 3? So you can either take 3, so 1, 3, so that finishes it. So you have one combination done. Or you can take a 2, and then you have one target left. And then with that one target left, you check the full array again and see what's missing to build the rest of that. But then also you could have taken 1, and then that would have put target as 2, and then you would take the full array again and look at see how you can finish 2. So basically, it's a super long tree.
No, so that sounds like recursion.
Yeah, that's what I'm saying. So if you're doing recursion, you want to DP it.
I see. Okay.
Yeah, because that was my brute force thinking of how to solve it is recursion, but then recursion is too slow. So, typically if you have slow recursion, you want DP. So in that sense, I was thinking for if you're doing DP, you want memorization, And if you're memorizing something, what I'm thinking is, for each target, if you already know the combinations to build each target, you can just store the number of combinations per target.
Right. However, I guess. So do you remember the coin chain problem?
Yes.
Okay. So this is kind of very similar to that, right? Let's say you're like, oh, to get to 4, I want all ones, or like 2 ones and a 2, and then a 1 and a 3, and like 2 twos, right?
Mm-hmm.
So if you do the coin change problem on this, and then you kind of keep track of how many 1s and 2s and 3s and such you've kept so far, right? Then afterwards, you can just do the expansion to get the differences between 1 1 2, 2 1 1, and 1 2 1, right? So
What do you mean by the
DP
differences?
is correct. DP is correct, but normal DP will not allow you to differentiate between what you have and in what order, right? Because you're going from like smallest number to largest number, let's say, right?
Okay. But what did you mean by you
All
said
right. So if you like if you want to make 4 cents and you have a 1 cent and a 3 cent, right?
yeah,
If the 3 cent goes first or second, it doesn't matter.
yeah, it doesn't.
But so as for the DP problem, uh, if you do the thing where you like add them up and then if you if you're adding the counts each time, then you're going to miss out on the parts where they're flipped order, let's say, right?
Oh, you're saying. Oh, I see what you're saying. It's because ordering doesn't matter here. You want both.
Right. So for the coin change problem, you don't have to care about order. So, but later on for accounting, you will have to care about order. So then, how do we change it so that we don't just store the count, but instead we store like what we have so far?
Yes. Okay, so yeah, that's okay. I guess that's the problem with that solution. So I think in the coin solution, we just realized the pattern, and then we used
So
it.
it's not quite a pattern, right? Like it's more like what? It's more like oh, sorry. Okay. So so basically it's like what can you make with a coin of you know uh, if the coin is value 1 cent, right?
Yeah, but yeah, so it was like basically given the coin array, you're building the array of from 0 to target in the coin case, and then basically for you're only slotting in to the indexes that you can build, and the ones you can't build,
Exactly.
yeah.
Exactly. So you can do the same thing here, where you initialize a DP array of size, let's say target plus 1. We'll add the 0 here just so we don't have to fiddle with the indices, right? And then basically you go through and say like, oh, if I'm at 1 and and my coin is 1, then I know I can make it because I just use 1 coin, right?
Yeah.
Right. And then basically for anything after this one, you're like, oh, when I subtract the coin size, could I make stuff? And if I could, I should just update it by saying like, oh, I'll just add 1 coin to it, and then carry that along, right?
Not totally following there.
Okay. So, right, if you remember the coin problem,
Yes.
basically your array would have been like 0 0 0 0 0. Let's say you use the first example. It's going to be 4 zeros, 5 zeros, let's say, right?
Mm-hmm.
And then when you reach index 1, because the nums of 0 is 1, right?
Yeah.
You're going to be like, okay, I know I can make 1 because I just used 1 coin, right? So then you just set that to 1. So it's going to be 0 1 0 0.
You know you can make 1 because you just use 1?
Right. If you start with nothing and then you want to make that coin, you have that coin. then
Oh,
then
you're saying in that case the coin was the value was 1.
you use one. There's one way to make sums, or
Wait, so yeah, just
it's really hard to talk through this without any example.
yeah. So all right, let's write it down. Okay, so in the coin case,
So let's assume this is the coin array.
yeah. So let's assume So I'm gonna write it down. 1, 2, 3.
What would the
1, 2, 3 is your coins, right? And then your
four.
DP. So your target is 4 in the sense that that's the value you need to build, right? Okay,
so the last in fact we can not worry about the 0, but like we're gonna leave it there, so indexing is nice.
Yeah. So
Okay.
in the coin case,
So you process the 1 coin.
yeah, so the 1 coin you need 4 coins to build target.
Well,
Well,
sure,
was it unique coins or was it
no. It doesn't matter, right? Using 1 coin, how many ways is there to make 4?
Oh, it's how many ways. Okay, wait. That was that the coin problem or is this problem? That's
It's a variation, but it's
no, but the
same
coin problem wasn't that, right? I might be misremembering here, but it wasn't.
I think it was not that, because you could save on number of coins by using a bigger number or something. Like,
Yeah, it was how many number of coins to build it, right?
right.
Yeah. Okay,
How
so
many
that's
different
different from this.
ways-
This is how many combinations to build, right?
I forget. It's very similar.
No, this current question is how many combinations.
Sure. Let's say you're using only the 1 coin. How many ways can you?
There's only one way to do it
Why?
because you can. It's only 1, 1, 1, 1. There's no other way to build 4 from ones
And why is it 1 1 1 1?
because you need 4 of them.
Right, but why do you start with the first one?
Oh, what do you mean?
How many 1 coins does it take to make 0 target?
I guess it's 1, but then
Technically, no. It's 0. Right? You can't make 0 with 1 coin.
okay, sure.
How many 1 coins? How many ways to make a target of 1 using 1 coin?
1.
Right. So that's where you start. Like if my target is the number that the coin is representing, then I just give it 1 coin and I'm good.
Mm-hmm. Okay, but then all right. So then you're saying now if the target's 2 and using 1 coin, it's still 1 because there's only one way to make it.
There's one way to make it, but at index 2, you're looking at 2 minus 1, right, and seeing like how many ways to make that.
2 minus. Oh, I see. Because you already put 1 coin in.
Right.
So that means how many ways to build the rest of the target, right?
All right. So if you do the coin problem here, it's the DP of the first coin is going to look like 0 1 1 1 1. Right?
No, wouldn't it be 0 1 2 3?
Because you only have 1 coin.
Yeah, but then you are you talking about the coin problem or this problem? Because that's different.
We're talking about this problem.
Okay, then it's not this.
But we're talking about half of this problem because we don't want to care about the other half of it.
Sure.
If you have 1 coins, only 1 coins, how many ways can you reach a target of 1?
1.
Exactly. How many ways can you reach a target of 2?
Well, in my mind it's 1, but it seems like you want it to be 2.
No. It is. You're correct. It's 1 because
Okay.
you just used 2 1 coins. How many ways can you make a target of 3?
1.
Exactly.
Okay.
So that's what I'm saying.
And then
This
4
is the part that looks very similar to the coin problem, the coin change problem.
yeah. Except it's
Okay.
not really.
No,
It's
not really.
it's
But,
a little bit like it.
right. But the thing is, this count of how many ways to do it, in fact, should be this DP array on the left is equal to DP array with dictionaries, right?
What do you mean by DP array with dictionaries?
So just move to the right and say equals. Oh, you're not typing? Okay.
Wait, what do you want? What are you talking about?
I don't know. So you're gonna have an array, and each array will have a dictionary at each spot.
Each array will have a dictionary at each spot.
No, this array will have a dictionary at each spot. So you're gonna have 5 dictionaries.
5 dictionaries? Oh, okay. Oh, you mean each index of this array has a dictionary. Or
Right.
each
And
index of this array is in a dictionary.
No.
No. Okay. I have no idea what you're talking about then.
Okay. So in the 0 index,
yeah,
how many 1 coins did we use?
0.
Right. So then you don't have to put in the dictionary. It's just gonna be empty dictionary. Right. In the 1 index, how many 1 coins did we use?
1. Oh,
right.
yeah,
so
1, yeah.
1 colon 1, right?
Yeah. So you're saying build a dictionary for each index in this array.
I mean, how else are you gonna figure out what the hell was used?
Oh wait. Are you saying build the combination out in the dictionary?
Well, not the combination, just the set of coins used. Then you can do combinations on the set afterwards.
So each index of this array, you're building a dictionary of what coins were used in this index.
Correct. And because you're using this coin, that means if the previous, I guess I minus coin position had stuff, all you have to do is add a 1 coin to it. Add a 1 to the counter. Or sorry, increment the counter of the 1 coin. Right?
What counter? What counter are you talking about?
Okay. Just write out indices 1 and 0 in this dictionary array.
Okay, so you said 1 and 0?
0 first.
Okay, so 0 is 1. 1 is 1.
Oh. No. that no. Okay.
What's wrong with this?
What? No. You want the analog of PP of the first coin, and using an array of dictionaries.
An array of dictionaries?
Keep track of what coins are there.
Yeah, so isn't this keeping track of what coins are used in each index?
In index 0, did you use 1 coin?
Yeah.
Really?
You said. Oh wait, no. You use. Okay, this is nothing. This is empty. Or.
In fact, you don't want 1 dictionary that holds this. You want a dictionary at each index.
Okay. A dictionary at each index. Then what's the key for it?
Well, I mean, it's going to be an array, so the key is just the index.
But then why would you need it? Okay, so you're saying.
Well, the whole point of this dictionary is to count all the coins you have used.
Okay, but then why do you need it stored as a dictionary? You're just storing an account.
Okay, how are you going to count if it's 2 coin, the 2 coin versus the 1 coin?
Does that matter?
It does matter because 112 can be done 3 ways versus 13, which is done 2 ways.
Okay. Not totally following, but sure.
So if you use 2 1 coins and 1 2 coin, how many ways can you rearrange this?
2 1 coins and what?
And 1 2 coin.
Okay, and what do you want?
How many ways can you shuffle this around and still build the same thing?
You got 1 1 2, 2 1 1, 2 1, 2, 1. And
Yeah, that's it. Those three, right?
yeah.
So this is why you have to keep track of what coins are there and how many of them you have. You can't just keep the count of the coins. If you know you have 3 coins, it could be 2 and 1. It could be all 3 the same. It could be 1 of each.
Mm-hmm.
Don't know.
Okay. So you're storing a count of each coins per index.
Right.
So basically, your dictionary is a dictionary of it's a dictionary of dictionaries.
No, it's an array of dictionaries. You still need the array because you're doing DP. You need the dictionary to keep track of the count instead of just a 1.
What
1 is like how many ways.
Array of dictionaries? Okay, so when you have an array,
So you currently have an array of numbers. You want to convert this to an array of dictionaries because you have to keep track of the counts.
when you're saying array of dictionary, are you saying one array that holds in a dictionary at each index? Is that what you're saying?
Yes. Right now you have one array that holds a number at each index.
Yeah.
You want that number. This number will not tell you what the breakdown of what.
Yeah, I understand that. So yeah, okay. So you're just saying an array, and then instead of integers, we're having dictionaries instead.
Correct.
Okay, and each dictionary holds the key of the coin used and the count of the coin used.
Exactly.
Okay, I get it.
What will this dictionary look like? For coin 1.
Yeah, so it will look like this. For coin 1, what you said, coin 1? Or what? For index 0? Which one are you talking about?
The analog of line 5, but using a dictionary.
So just build the whole thing. You say, okay. So okay. So for this first one, no coins are used at all, so we don't care about that. First index. So index 1 is index 1.
You don't care about that, but you still need the dictionary. You need an empty dictionary.
What?
There's no coins used at all, but you want an empty dictionary at index 0.
Sure, that's fine. Okay. So this one would be 1 coin used. The 1 coin was used, and only 1 of it was used. And this one is the 1 coin was used, but 2 of them were used. This is 1 coin was used, but 3 of them were used. This is 1 coin was used, but 4 of them were used.
Exactly.
Okay. And then you just want to do this for every single coin.
How do you build this array out?
What happened?
How do you build this array out?
Well, I can build this in a loop, but
okay, what would this loop look like?
Okay, so given this array, actually no, not given this array technically, is
that array you can calculate afterwards, right? Because you know that the number of coins used is only 1, and you have 4 choose 4 equals 1 from just this 1 coin.
Mm-hmm.
Okay.
So yeah, I guess it would be like so you're given, so it would be like for I in for what is this stuff called? Num. Oh, we want.
No. Why are we dividing? We don't want the weight.
We want the index, I think.
Well, first you need to initialize DP to be length, basically target plus 1 size. Right?
Sure. Well, it wouldn't be numbers, it'd be dictionaries. Okay, so this is, I'm looping through the numbers here. So the first one is 1. So if it's 1, I need to check to see if I needed a coin to build the 0th index. So I just need that logic.
Needed a coin to build the 0th index. Oh, kind of. So memo of, so you should loop starting from num index, right?
You said num comma index, right?
Well, you're looping through a memo a bunch of times, but you should, for each num, you should start at num, because num minus num equals 0, which is the first index.
Num minus num equals 0. Yeah, so you, so you're saying, wait.
So you don't want an out of bounds thing.
So wait, are you looping through the memo now to build it?
You have to do the memo. That's how you build the whole thing, right?
Yeah. Okay. So the thing is,
So let's not do it for num and nums. Let's just assume that num is 1, right? So how do you build memo to look like line 12?
yeah, that's what I was trying to do. But then, yeah, this case is just the entire array. But then I'm just focusing on 1 for now. So
Yeah, sure.
num in this scenario is hardcoded to 1. Well, it starts off 1 anyway.
Right. So where do you first put the one counter?
What 1 counter are you talking about? You talking about?
For this coin, where do you first add 1?
Where do I first add 1? Well, in the first index.
Why is it the first index?
Because you can't build the 0th index.
Right. But what if the coin was like 2? Okay.
You can't. 2 can't build the first index either. I mean, yeah, the 0th index is unbuildable.
You cannot build a 0 index, but where would the first 2 show up?
Oh, the first 2 show up in index 2.
That's right. So then that means you should start from index equal to num, then go to the end, right?
Yeah.
Okay.
Okay, so index equal to num. Okay. Oh, so for I in range memo. Right, that would force you to start at that index.
That's fine.
Okay. And then that means for each of these memo instances, we need to calculate how many coins can build that current number. So
Right.
yeah, so if I'm starting at 1, I only need 1. But the logic for that is, isn't it just division?
No, why division? No. We just want to store the coins first. We'll calculate the combinations later because we haven't.
No, yeah. So that's the problem, right? So then,
Problem.
because then, okay, so let's say you're on index. Let's say you get to the second index, right? Index 2. You
Okay.
need 2 ones to build it. How do you know how many ones you needed to build it?
Right. So, I mean, you know it's 2 because if at index 2, 2 minus 1 is 1, and you know that it took 1 to build index 1.
Oh, so you're just adding 1 to the previous one.
No, you're not adding 1. You're incrementing the counter for this coin.
Yeah, well, I mean, like your count for the next index is the previous count plus 1.
No, your count for the next index for this coin is the previous count plus 1. But it could be, you can have several different coins. Like
Sure, yeah, okay, but you said we're focusing on one for now.
let's focus on one for now.
Yeah. So you're basically incrementing the count of the previous coin by one, right? And previous coin is just one in this scenario because we're not focusing on any other coins.
Sure.
So it's just the previous indexes count plus one.
No, it's the previous index because it's num minus one because coin is one. But if it was two, then the previous index would be two away.
Previous index is two away.
Yeah. I mean, we could do that example also, right? Let's say coin was two, and then we wanted to build target four, right? It would look like 0, 0, 1, 0, 1, right?
Yeah, so you can't build 0, you can't build 1, you can build 2. You can't build, you can kind of build 3. Right? I mean, you can't fully build it yourself, but you need...
No, you cannot build 3.
It is a combination though, isn't it?
You only have the 2 coin. You cannot build 3.
Oh, well, you don't only have it.
So let's say we only have it. So then we don't have to worry about like this assumptions about the previous index and stuff. Like if you use the 2s, then it should be very clear why or how to get the next thing.
Yeah, that's fine. That's fine, but it looks like this solution won't be correct then, right?
No, don't worry about that part. Let's use the example where we're trying to reach 4 and we only have the 2s.
Yeah, I just did it.
Well, your 1:3 is not right, and your 1:2 is not right, and your 1:1 is not right.
No, that's
we
right.
Don't want any,
that's right because this is both cases. I just didn't delete it yet.
Only one case.
Okay, but all right, that's fine then.
Okay, so how did you know to put 2 in position 2?
Because it takes. You can build it.
Exactly.
One
you
coin.
can build.
Yeah.
How did you know not to put 2 in position 3?
Because you can't build it.
Why is that?
Because when you minus 2 from 3, you have 1 left over, and you can't build that 1 with a 2.
Okay, and then in position 4, how do you know to increment 1 for 2?
You can build it with 2 2s.
That's right. Okay, so what is your loop that allows you to
Yeah, you're basically jumping indexes by multiples of your current coin and just incrementing by 1.
Well, I mean that's what it looks like, but in the for loop, how will that be represented?
It wouldn't be represented. I guess you just have to have if cases to handle it.
No. So basically, I mean that's I mean, sure, but not really. So in this case, at position 3, right, at position 4, why do you look at position 2?
At position 4?
Huh?
You say index 4, why did I look at index 2?
No, at position 4, what is the what's the relation between position 4 and position 2? What's the relation between position 2 and position 0? And what's the relation between position 3 and position 1?
They're all 2 apart.
Right. Which is the size of, which is the coin size, or the number, right?
Yeah.
Okay. So at position 2, you know you can make you can just put it there because it's 1, right?
Yeah.
You just basically you initialize it with the count is 1.
Okay.
And then at position 3, you're looking at position 1 and being like, for everything in there, I just have to add a 2 coin and I can make this, right?
For everything in there? What do you mean?
So let's say you can make something in position 1.
Yeah.
If you're using a coin of size 2 and you want to make and you want to move everything in position 1 into position 3, you just have to add a 2 coin, right?
Yeah.
Okay. Same thing with position 4. You look at everything from position 2, and then all you have to do is add a 2 coin, and you're good.
Yeah.
Okay. So does that tell you why position 3 is empty?
Yep.
Right, because position 1 is empty.
Mm-hmm.
And position 4 is not empty because position 2 is not empty.
Uh-huh. Yeah.
Then we just ignore position 0 because that's
okay. So I think I know what you're saying. You just
you want to
you checked it if it's in the dictionary, and then you just increment it and then put it back.
No, that's not in the dictionary. Because there's going to be other coins, but you want to check everything in the position that's num smaller than your current position, and then basically append a 2 to that, or append a num to that, right?
Okay, so you're just checking the index of your previous one. So currently num here is 2. So you would check memo 2 minus.
No. You don't have to worry about that because that logic fails at the beginning because then you're adding 2 to nothing, right?
Yeah, no, but then that's why you check to see if it's there, right?
No, you initialize at num, and then everything after that you check index minus num.
So you do it outside of the loop, but then
I would do that.
If you do it outside the loop, it's gonna do it again inside the loop.
You do for range num plus 1, right?
Sure.
Yeah, memo num should equal or no dot. And
No, you're
white.
No, your memo num is a dictionary.
You might have some values in there already. You don't want to overwrite them.
Yeah, so you're adding to a dictionary. So it's memo num. Wait, num is the coin. Yes, that's correct. So it's both. It's the coin and the index currently at the starting position anyway. So that would equal 1.
Right. So in fact, your DP should have several of these things, right? So your DP should be an array of arrays. Then each of these arrays can have a bunch of dictionaries.
Wait, why do you need so many arrays?
Okay, let's say you don't need those arrays. Then how will you do it?
Well, aren't you just, since you have a dictionary at each index, right? And it will just have all the coins.
Let's forget that. Let's just do your way. That's fine.
Wait, what's my way?
This memo stuff.
Oh, so just leave this?
Sure.
Okay.
And then when we run into a problem, then we'll fix it.
Okay, so this initializes the first one, and then this one is shouldn't this be num plus num? I guess it's fine. Okay, so if wait, did we need it initialize that outside? We could have just have an if check.
You're checking the position of.
No, I is the index that you're currently looping through, right?
And then if you're using num, then you should have been num smaller.
What do you mean num smaller?
So when you're at position 3, you're checking position 1.
Position 3. Yes. Because you're minusing num.
Correct. So it should be I minus num.
Okay, yeah, sure, but you still have to pull out the dictionary, right?
Right. Wait, yeah, it's gonna be a while.
I don't think we need this.
Okay, but you start with nothing, so everything's just gonna be 0.
Does it do that? Oh yeah, I guess it does start. Yeah, that's true. Okay, that's fine then. Yeah, this is fine. This appends 1 to all the indexes that have a dictionary.
Right. The problem with this is that there's multiple ways to do this, and for each of them, you should be adding this coin, right? So let's say, let's say we did the 1111 stuff, right? And we're like, okay, we have 111s, and then at position 3 now, you're looking at position 1, and there was we used one coin.
Yeah.
Oh, maybe that's not right. Let's use position 4, and we process the ones, so it's 1, 1, 1, and 1, right? So at position 4, you're looking at position 2, and you're like, okay, position 2 has two copies of 1.
Yeah.
So right now you're saying for position 4, you're taking position 2 and saying it's 2 copies of 1 and 1 copies of 2.
Yeah.
Right?
Yeah.
Right, which works in that case. But what happens when you move to position 4 and taking using a 3 coin and taking position 1?
3 coins in position.
You know, your dictionary has to. You have to have more than one dictionary that does this.
I don't see. Wait. What? Say 3 again. What were you doing with 3?
Right. So you process the ones.
Yeah.
Right. And so position 4 has 1:4.
Yeah.
Okay. Now you're processing 2.
Yeah.
Position 4, it's position 2 plus 2.
Yep.
Right? But it's already 1:4. Then how the hell do you have 1:4 and 1:2 and 2:1?
Wait, why would you need all that?
Because those are discrete ways to do this.
No, so 4 position will be 1:4 and 2:2.
Yeah, but what about 1:2 and 2:1? That's also possible.
Yeah, but not in the current way.
Because it's not possible in the current way because like you don't keep track of everything that was made previously.
Exactly. But there's no way to even do a 2:2.
No, there is, because if you have an array of this stuff, then you just add to every element in the array, which is the dictionary. So then the dictionary for position 2 will be 1:2 as one element, and then 2:1 as one element, right? So when it gets to position 4, then you take 1:2 and then you just add 2:1 to it, and then you take the 2:1 and you add the 2:1 to it, which is 2:2. So you have both of them.
But what do you mean you're adding a 2:1 to a 1:2 and a 2:1?
Okay. Position 2. How do you make it?
What do you have currently?
And 2.
You have a coin 2. That's it.
A coin 2 and you have a coin 1.
So it currently is 1:2 and 2:1.
That's right. So both dictionaries need to exist at position 2.
Well, it has one dictionary of both values, right?
No. Because then you can't mix and match.
What do you mean by why can't you mix and match?
Okay. Okay, then position 3, using 1s and 2s.
Okay, 1:3, 2:1.
And
3:1?
no. 1:3 is one way to do that. 2:1 and 1:2 is another. Sorry. 2:1 and 1:1 are both required to make 3.
So you have to store the actual complete set.
Yes.
But the problem is, how do you know that? How do you know? Oh wait. So are you saying?
It's not possible to reconstruct it without knowing.
Yeah,
all the ways
but
to make it.
it's not even possible to construct it at all. Are you saying
But it's
that?
possible.
Are you saying that when you're looping through the indexes, you're pulling down every single dictionary that exists and you're just adding one to each of those?
You're not adding 1 to each. You're adding 1 to the current
So
number.
the index of that's supposed to add to it.
If you're dealing with the 3 coin, you're only going to increment 3s. If you're dealing with 2 coin, you're only going to increment 2s.
I see. Okay.
You're doing
Okay. Yeah. So you have an array of dictionaries.
an array of array.
Yep. So your outside thing, your memo is an array, and then in each element of that array, you have an array of dictionaries.
That's right.
Okay. All right, I got it.
And then for each array that has existed, for each dictionary that has existed previously, you just append your new guide to that. No, you don't even.
No. You're pulling down all the dictionaries for each index, and then you're appending one to the number that you're currently caring about.
Correct, but you should not initialize it to this. You should get rid of the empty dictionary, because then that will now count as an element, which you don't want.
Wait, what do you mean?
You just be
just empty array?
It should be the array on the outside, and then empty array for do empty array times length of nums plus 1 inside of the bigger array.
Wait, why do we not want the dictionary inside?
Because that now counts as an element. If you do for element in array, empty dictionary will be part of it, which you don't want.
I mean, it's fine, right? Because then, if it's empty, that means we don't do anything to it. If it's not empty, then we start interacting with it.
What's the point of even having it? It doesn't make sense.
Okay, but if we don't have it, yeah, I guess that's fine. We don't need to have it, and we're just gonna put it in anyway. Okay, so this wouldn't be memo num of num. It'd be memo num dot append.
Yes, exactly. The dictionary that you care about, which is num:1.
And then this one would be fix equals memo num. So that's an array of dictionaries, and then for I and
I minus num.
no, we're just looping through the dictionaries, right? Why would you minus it?
Well, you don't have to loop. Wait, hang on. You're not looping at the current index. You're looping at the previous index.
No. I'm pulling out the dictionaries. Oh, you mean this is -1? Or no? Wait, no. It's I minus num.
You're using I twice, so let's not do that.
Yeah. Wait. Wait, is this correct? I minus num. So we want the dictionaries. Yeah, we want the dictionaries of the index of the current index minus num. Okay, yeah, that makes sense. Now we loop through all the dictionaries within this dictionary, and we only interact with the ones that are current index.
Right, but you want to add it to a new thing.
No, we're making new dictionaries to add to the new thing. Yeah, that's fine. Okay, so if dict memo of num.
For dict, why are you checking if dict?
We're making sure the dict exists.
Well, if you're looping through that element, it has to exist.
That's true. Okay, fine.
Not quite append. You're.
Wait.
Wait, what the hell?
Wait, no. Memo you're append.
Well, you want the whole dictionary, but you just want to increment the num count.
Yeah, but at this point you don't have a dictionary, so you have to make a new dictionary. So you're appending the dictionary to the array.
Right.
Yes. Because then if you're looping from left to right, that dictionary is guaranteed not to exist for that specific num.
Not strictly so.
Alright, then I can just do an if check. If memo num.
If num is dict or something.
Yeah, if num in memo. No. Num. Wait. What? No. If num in dict. Yeah. Then you do dict num plus 1.
Well, you might be editing that thing in memory, so you don't want to do that. You want to basically recast it. Just say something like d equals dict.
What are you talking about? Where?
You're now probably editing that value in memory, which is not good.
Oh, you mean like when I said plus equals 1?
Yeah.
So I have to actually pull out the thing and set it and put it back in?
No, you just copy it and then you append it to the new guy. Whoa. No. D is the whole dictionary. It should be like D equals dict of dict or something. Or D equals copy of dict or something like that.
Why do you need a temporary copy of it? That makes no sense.
You just need a copy of it. Otherwise, you're going to be editing that guy in memory.
What's wrong with that?
Just don't say equals dict, because then it's the same pointer. You need to do a copy, basically.
How do you copy?
So if you call the data structure creator on the same data structure, it makes a copy of it.
Oh, you mean like that?
So you can say dict of dict.
Like the parentheses, right?
I mean, your variables are like pretty horrible.
Well, yeah, that's why. Alright, I'll just use the full name. Okay, and so now the new dictionary of that dictionary. Now we want to set the num. So there's one.
I would move line 25 to like 24.
I don't have a line 25.
15 to 14 I cannot read.
Wait, you're plusing one before you make the dictionary?
Plusing 1 is 16.
Wait, you're moving it. Oh, you're just condensing the if statement? Why? That makes no sense.
Oh, you clone first and then you check stuff.
Okay, so you're saying for each dictionary and dictionary, I'm just gonna clone it instantly.
Oh, I'm saying swap 15 and 14.
Yeah, that's what I'm doing right now. So you clone it instantly, then you check if it's in D.
Also careful about your spelling. They're not matching.
Are you sure?
Yep. Okay.
Why is it spelled like that? Okay.
If num is in D, then what do?
If the current number is in D, then we increment it and we put it into the new one.
Okay, that's fine. And if num is not in D,
Wait, then we make a new one.
you should do it at the end.
Oh, it's at the end.
You didn't handle the else for line 15.
Yeah, I didn't even handle the if yet.
Oh, you did handle it.
No, I just plussed one. I didn't put it back in.
It's after you handle the else.
Wait, I put it back in after I handled the else?
You also don't put it back in. You just make a new array and use append to that.
Okay. Wait. So I'm moving to the dictionaries. Yeah, so I have all the dictionaries of each. I have an array of dictionaries.
You should probably have something like new dictionaries somewhere. That is an array that you can store these things in.
What are you storing?
You're storing the new dictionary that now has the updated value for this guy.
Wait. So this.
No, not there.
No, this is. I'm trying to visualize the data structure because this is so confusing.
Yeah, I can tell you're very confused.
It's an array of dictionaries. Okay, so that's why when we pull down each element within this array, we're looping through the dictionaries. So that's for dictionary and dictionaries. We're making a copy of that dictionary for some reason, and then
Well, the reason is because you don't want to edit the previous guy. This is a new entry.
oh, so you're just copying it because you're putting it into the new array.
Right. So
Oh, that's what you were doing. Okay, okay. I was just gonna loop through the dictionary and just build a new one, but okay, that's fine. That clears up why you're copying it. Okay.
Right. So then you can do memo of I append this new thing.
Yeah. Wait. Why do we do num in D? Okay, so we're incrementing one into the one that matters. Okay, and now that we have the new dictionary, we're trying to append it back to the memo.
You didn't handle the else case, so you should handle the else case before you append it.
Well, the else case is appending it. Else,
No.
if num is not if num is not in dict, that means you have to add it to dict.
That's right.
Yeah.
That's the else case. That's
What I'm saying. But isn't it the same thing? Oh wait, no, it's not the same thing. Okay, so else. Else does not exist. You have to make a new dictionary.
No, you have to make a new key.
Well, you have to make a new key in the current dictionary.
Yes.
Yeah, but then you don't want to mess with the old dictionary, so you're still using D. So D num equals 1.
You're going to append. You're not going to deal with the previous guy anymore.
Wait, is it 1? If it doesn't exist, oh yeah, that means you never did anything. Okay, and then
you're only going to do 1 coin.
Okay, now we put it back into the memo. The memo's num.
Memo of I append.
Is it I?
What is memo of num? Memo of num is going to be like 2 or 1 or 3. You're never going to change 4.
Yeah. Okay. Yeah. The target is what we care about. Wait. So this memo. Okay. Okay. Wait.
I think it's going to be very useful for you to print out memo after each loop.
Yeah. I mean, if this even works.
Oh, this is only half of the problem, by the way. The other half is queuing this and then getting the combinations.
That part should be easier.
I hope so.
Is that true? Memo I dot append D. So you're appending new dictionary into the index that you're currently at. Yeah, so memo I is the array at that index, and then you're just appending a dictionary to the index. Okay, that's fine. That's correct logic.
You should print it out at least in the first for loop, at the end of the first for loop.
Yeah, this is the end of the first for loop. Or this is the second for loop.
From over here. You don't want to print it at the end because then you don't see anything happen. Put it in the first for loop.
So you mean at the end of the second for loop? Apparently the syntax is not correct. Oh, you probably need parentheses. Something happened here.
Your spaces are wrong.
Oh. Index out of range. What is wrong with that? Num and nums. Oh, wait. I'm looping through the coins and the memo itself. Oh yeah, the nums could be bigger number than the actual thing.
No, it can't.
Yeah, it can. It could be like target like 12, and then you could have like a search like a I don't know 9 here. Wait, that wouldn't make sense.
Oh, you cannot have a bigger.
What if they What if they gave you a nums that's useless?
Look at the inputs, dude.
Yeah, I know that's the examples, but like look at this one, nums 9 and target 3. There you go. It's bigger than the target.
Okay.
Yeah, but that's not the current thing here. This shouldn't index out of bounds for this one. 1, 2, 3, and 4. Memo num. Num is 1. Index 1. That's fine. Almost 3. That should be fine too, unless memo is like not properly initiated. Yeah, that's why. Because memo is just one thing here. It's because it's empty. If empty array doesn't, you can't multiply empty array.
Okay, then say for I in range. So it's yeah. Change that to for I in range lang. No. You need the empty array first. Yeah. You need to close that parenthesis.
I did. It works.
Okay.
Okay, now no out of bounds, and then it has.
Does this output look reasonable to you?
Oh, I'm checking it now. So there's one way to make a 1, yeah. 2 coins to make the 2. Also this one coin to make. You need 3 of these. You also need this combo, and we have the 3 one. Yep. And then we don't have the 4, so we're missing the 4. What happened to it?
I think you need to do a +1 in your.
I did though, right here. Nums +1.
Oh, but in your other loop where you populate it, you don't.
Wait, where do I don't do it? Wait, no. It looks like it didn't do enough. This should have had 5 stuff here.
I know why. You did length of nums, not length of target. Not target +1.
Oh, you're supposed to be target. Okay.
It's not length of target, it's just target.
Oh yeah, it's just int. Oh, there we go. Now I got my fours.
Okay.
Okay.
Great. So now you see how if you index the target location,
Yep.
you'll see that there's one way we use all 4 ones. And then there's a set that uses 2 ones and 1 2.
Yeah.
There's 2 2s and then a 1 and a 3, right?
Yeah.
So then now you have to dequeue this and count the number of ways that each of them can be done.
Yeah. Okay. So basically, we only care about the last one, so we do memo -1 result fix equals this.
Oh man, this better be a hard problem because it's freaking involved.
Well, you solved it fast, right? It's just hard for me.
I just thought it was sketch and I didn't actually solve it.
Oh, you didn't? Okay.
But I guess you walking through this for an hour shows that it's
It's very difficult for me, but it's probably not that bad for anyone else. It's just hard to visualize for me.
multiple steps.
Okay, so results equals 0. Then we literally do. Okay, so one coin used 4 times is just one combination. 1 coin used 2 times and 2 coins used 1 time is, that's supposed to be 3, but how do you know that's 3 given just that thing? And so
you know, because so the math here is if you add up all the things inside of the keys, the values, right?
Yeah. Oh, you're just adding the occurrences?
No. So
that
in
is
the
a
one colon 1, you have 2 copies of one of them and 1 copy of another, right?
Yeah.
That means if you take the sum of 2 and 1, that's 3, right?
2. Yeah. Okay.
That's 3 factorial divided by 2 factorial, 1 factorial. That's the number of ways.
Oh yeah, that's permutation. I don't remember that formula.
Alright, so for you to create a combination of a collection of objects, if you have duplicates of those objects, then you just take the sum of the total number of objects, and that's going to be the numerator. And then you factorial that, and then you divide by each count factorial.
Okay, that made no sense. Okay, so look at this example right here, right? So you have this 1 occurring 2 times and a 2 occurring 1 times. You're saying I take the sum of the counts, which is 3, and then I divide by and I multiply by factorial?
No, the top part is going to be 3 factorial.
3 factorial, okay.
And the bottom part is going to be each component factorial. So it's going to be 1 factorial, 2 factorial.
1 factorial, and then you're adding those or what?
Go ahead.
So you're saying the formula is the 2 counts combined factorial divided by the separate factorials of each of them.
Nice.
So that's the formula?
Alright, so if you have, let's say you have, 2 counts of 1, 2, 3, and 4. Let's say you have 2 1s, 2 2s, 2 3s, and 2 4s. Then it will be all of them added together, which is 8 factorial, divided by 2, 2, 2, 2.
Yeah, so 2 2. Wait, where did you get 2 2 2 2 2 from?
I'm giving an example.
Oh, okay. No, but basically the gist is in this example, right? The 1 comma 2 and the 2 comma 1.
Mm-hmm.
You're just taking the 2 plus the 1 into and then you multiply and then you factorialize that, and then you divide by the sum factorials of all the counts.
What? No. For each count, you take the factorial and you divide the numerator by that. So at the end, whatever you have left is the total combinations for that particular set.
Okay, wait. That's just way too confusing. All right, how about this example, just to confirm? So in the 1 and the 2 is that 2 factorial divided by 1 factorial plus 1 factorial?
Not plus, times.
Okay, but so you're saying this is times instead of plus?
That's what I've been saying.
Okay, but is this the correct formula? Is it 2 factorial divided by 1 factorial times 1 factorial?
Right?
Is it?
So, you can list them, right? It's going to be 1 and 2 or 2 and 1. There's two ways.
Yeah. I mean, I can list them, but I can't confirm if the formula is correct.
I can confirm the formula is correct.
Alright, yeah, so just confirm. Okay, so I know the formula now. Okay, so given that formula, does that mean I have to define a factorial function in here too?
Well, probably.
Oh my god, really? Do I have to memorize factorial too? Because then it's recursion.
That's how you do it. Just to say fact equals and then 0, and then for I in range, I don't know, n20.
No, factorial is a recursion method.
Yeah.
Yeah.
You just multiply the last guy by that.
Yeah, and then I have to do memorization for it to make it faster because factorial is super slow.
So then you can just have a factorial memo.
Yeah, I know. So I'm gonna do that with. Yeah, so I need to define another memo. Okay, this is very fun. Okay, why do I have to do 2 memorizations within one problem?
Because that is the way.
Okay, so the factorial memo. Oh my god, I can't even do this one. This one's so easy. Okay, this one is it's just a dictionary. It's just a dictionary. And then if you did that factorial already, you just can pull it out and multiply. You don't have to do it again. Okay, that's fine. There. Okay, so factorial, if n in fact memo return n return n, yeah, return n, yeah, that's fine. Else return fact n minus 1 times, what am I multiplying here? No, you don't need to multiply. You just return -1 because it'll come back in here. I checked if it's in there. Wait, but then, when do I do the multiplication part? Do you need to do something here? What is the code for this? I think it's n times a factorial n minus 1. Yeah, that should be correct. Let's just call it, check it out. Oh my god, alright. Just gonna return this pass for this one. Why is it running so long? Oh, alright, so I guess that's not exiting.
What the hell? Ah, shit. Alright, maybe this one's supposed to. Oh, alright, now.
Wait, why is this infinite open? return n times n minus 1. Oh, wait, I never stored it into the dictionary. Okay.
Holy Jesus, what is this? Oh my god.
What happened?
Okay, I give up actually. This
Oh,
is
you're
something crazy.
this solution is not is TLE or something?
Yeah. And there's a part where they make you do a lot of crazy shit. Okay, forget that.
Wow.
This is the right way.
Well, it's the right way, but it's TLE. Then how's it?
That is hard. Like,
So you need something else to make it non-TLE?
it's fine, but
What's wrong with this method?
what? I don't quite get.
Why can I not figure this out?
Yeah, I don't actually know the best way to do this. It's silly, actually.
Mm-hmm. Wait, how come I can't figure out factorial? What am I doing wrong here? Is my brain broken that I can't even do factorial anymore?
Oh, so for factorial, all you have to do is initialize with 1, because that's factorial of 0. And then for anything from 1 to n, you just multiply the last guy by the element.
Oh wait, yeah, so you just do an array instead.
Yeah, I would do it right.
Oh, what the hell am I doing? Okay. Okay, sure, yeah, okay.
Okay, I think I go home too.
Oh, GG's. Whoa, you didn't even, did you spend over 30 minutes though?
It also looks annoying, or unless I'm thinking about it wrong, which is probably correct. Wait, did we overthink the hell out of this? What the hell?
Well, I didn't think much. The most of my thinking was trying to understand what you were talking about. And then when I finally understood what you were talking about, I'm like, okay, yeah, that makes sense.
I
in range n. If you're I in range n, so you go to 1, 0, 1, 2, 3, 4.
Yeah, we overthought the hell out of this. God damn it. Okay. The original approach doesn't require crazy shits.
Wait, you mean you don't need DP at all for this?
You do need DP, but you don't need the crazy thing where you store dictionaries and shit. And
then what do you do?
So we know that the numbers are. You just loop through numbers every time.
What do you mean loop through numbers every time?
Freaking hell. So if you have 1, 2, 3.
Yeah.
Basically do DP once, but then the inner loop is the numbers. Not. So if we switch the order, then it's much easier to do.
Say that again. So you have 1, 2, 3. What are you doing?
Oh, so you make DP.
Like how we did before?
Right. Except it's much easier because you don't need to check the combinations. Like that's the annoying part. Like, it's stupid.
Wait, what do you mean you don't need to check the combinations?
You don't need to keep track of the coins and such because if you loop through each coin, and you only append if it's possible.
But how would you know it's possible? As long as it's less than target, it's possible?
Definitely. Oh, God damn it. Okay, I overthought the hell out of
this. Wait. So basically, you're looping through this.
Let me change my solution first.
Wait, what? I don't know what you're talking about.
Okay, we go back to the numbers, right?
I'm at the numbers. I'm gonna get rid of the factorial.
Okay, you don't need factorial.
Oh crap, it was Sunday? Oh man. Oh well. I forgot to withdraw money. Can you solve it?
Yeah, I think so. Let's see. And it's so much simpler. Jesus.
Wait, so what are you doing?
Oh, it's really stupid. Much of the insight that we had is the same.
Yeah, but what is getting scrapped? The array of dictionaries?
The dictionaries you don't need.
So what
Okay.
are you storing
So
in
yeah,
each?
okay. So you start with DP where it's 0 for everything, right?
So similar to the coin one, kind of?
Yeah, exactly.
Okay, so
And then we're saying that there's one way to make 0. So DP of 0 should be 1.
wait, there's one way to make 0?
You just have no coins.
Okay, sure. Alright.
Right, and then for I in range 1 to the length of DP, so basically you're iterating through this stuff, right?
Yeah, alright, let me delete all this first.
And then for num in nums,
Wait, for I and wait, we're looping through the memo?
you loop into memo. Yes.
Okay. Sure.
And then for num,
Yeah.
you do the same thing where like if it's the first time you encounter num, right? So if I equals num, then the DP or the memo of that ith location is plus equals 1.
Okay. If
Otherwise,
you're saying if I equals none.
if I equals num, yeah.
Yeah, and then otherwise you don't increment.
Right, right.
Okay, but then that means you're only incrementing when it exact matches. But what about the indexes where there are multiples of I? Those don't matter?
That's fine, but it's accounted for there.
Oh, it is? Okay.
Oh, wait, no, then DP of 0 doesn't matter actually. We don't care about that. Let's see. That's true. Yeah, it is true. Okay. So DP is 0 for I in range, target plus 1, right?
Okay.
And for I in range, 1 to the length of DP or memo in your case. For num and nums, that means you're gonna loop through 1, 2, and 3 for the 4 case.
Mm-hmm.
If I is the num, then DP of num, the DP of 1 is gonna be 1. Plus equals 1.
Yeah.
That means for the first time you encounter it,
It's gonna be 1.
that index, you're gonna increment by plus 1. It's gonna be 1 basically.
Yeah.
Then after that, you're gonna add all the ones from DP of I minus num.
Yeah, together as a total, and that's your return statement.
So your return is minus 1.
So you're returning sum of the memo.
No, you're summing as you go.
Oh, I see. Okay.
So there's two cases, right? Either I is equal to num, or I is greater than num, or technically I is less than num. But then you skip that one.
Okay.
So it should be L if I greater than num.
Do we care about I greater
We
than?
do. Yeah, because that's where you do the actual DP stuff.
Okay, if I is greater than num, that means at that target it's still bigger.
That means you're looking from nums ago. So this is the part where you're doing 2 to 4 to 6 or whatever, right? So memo of I plus equals memo of I minus num.
Okay, so you're just adding the previous index, right? You're incrementing the bigger index by the index that was num ago.
Yes.
Okay.
And that's it.
And that shores up all your stuff. Okay.
Then the target location is gonna be
the last one.
No.
The last index.
For target, right?
So you're just returning memo negative
one or memo. Jeez, alright. I just completely went there on the wrong path.
Wait, so this works? Oh, it does
Right.
work.
Yeah, why not?
Okay, so yeah, so you had, so this algorithm basically says you're looping through for all the elements in memo, and then with inside that loop, you're looping through all the numbers. If if that number is equivalent to the current index, then you just give it 1 basically, because then it starts at 0. But if it's not equal, but it's greater than, then we're gonna start adding from the previous indexes to the current index.
Right.
Okay, so in that case, like in index 1 equals num. That's then at so memo I of some index 1 would have 1, and then when you keep looping, now index 2, it says, oh, index 2 is greater than num because 2 is greater than 1. Then you're just gonna pull that 1 from that previous one and put it back in here. So that's why this 0 becomes 1, and that's why the entire ones all are 1s at the end. And then when you do 2s, which at the 2 index, you'll add another 1 to it because that's another combination you can do. And then when you go to 3, it'll try to pull from 1.
Yeah, I think it might be instructional to just print out memo after the first loop.
It looks like this solution, it doesn't seem like it should work, but it does work. For some reason.
It does work because you're going through every single number. And so
but you're just adding 1s to how does that guarantee that it's always
print memo in the second for loop, not the first for loop.
This is the second for loop.
Inside the second.
Oh. But the thing is, like, it doesn't seem like it. How does it know that it's interacting with the, what is it called, the how does it know that it's a combination guaranteed? You're just literally just grabbing the 1s from it.
Print memo at the bottom.
Yeah, it's right here.
I don't know. You're printing it too early. Nothing is.
Wait, what? You said in the second loop.
No, but print at the bottom of the thing. Okay. This should tell you exactly how it works. Basically, at each index, you process that index only, and then you don't care about it anymore. So for index 0, you don't care. For index 1, you found the 1, and you're like, okay, we're good. And then for index 2, you're going through, you're setting it to 1 first, and then I guess you're also incrementing the previous guy.
Yeah, but you're summing the index that was like num ago also. So that part kind of makes sense. The part that doesn't make sense is how does it know that that's a combination? Like, how does that know that's instantly another combination?
Care about the combination because the order is already accounted for in this.
What do you mean?
So you see how there's 3 lines for 0, 0, 0, all the zeros?
Yeah.
Because nums is 1, 2, and 3, right?
Yeah.
You should have 3 lines for each thing, right? So after the first line, it's 1, 0, 0. Then after the second line, it's 1, 0, 0. And after the third line, it's 1, 0, 0. Because we're dealing with just 1 at index 1, right?
Yeah, sure.
And we're dealing with index 2. So right. So index 2 is just the current location minus the previous one, which is 1.
Mm-hmm.
And then at index 2 for num equals 2, you're adding 1 because 2 is equal to I at that point.
2 is equal to I. But yeah, when you're on index 2, 2 equals I. Yeah, sure. So that's why you.
3 is bigger than. Care about it. So then 0, 1, 2 becomes the thing at index 2. Then at index 3, you're adding 1 again because
it's another 1 of it.
Sorry, no. For our num equals 1, then you're just taking the previous guy and adding it to your current thing, which is 0, right? So
So
position.
it's always just a running total of how many combinations you have.
Right, and all the combinations are baked into each of these also.
Yeah, that part is not really understandable though. I don't know how it knows.
Well, if you want to see what the combinations are, you would just store them instead of the number. So what you did before.
Yeah, so the before method you can see it, but this one is it's just counting the total. It doesn't care. It doesn't care about the combinations. It's just counting it. It's the only thing I just don't fully understand.
What do you not understand about this?
I don't fully understand how this knows that that's the correct combination count. Just because you added it doesn't. How does it know?
No, you only add it if it's possible to add. So basically, if so, I guess the count also implicitly states that like, if you store all the dictionaries, you would see them all. But you don't store the dictionaries; you just store the counts. But for you to get from I minus num to I, you have to add one to or sorry, increment the count of num.
Okay.
If you want to see how this works, you should just replace all the numbers with the dictionaries as you saw before, and then you'll see it. This will not give you the timeout.
You mean just build the dictionaries?
I can code that and send it to you.
Oh wait. This is exactly what we did with the dictionaries too.
That's what I'm saying.
Okay, I see. Okay, you took no. I understood the part where you took the previous position, you just added one to it. Yeah, because that's what we did with the dictionaries too. We just added one as we went along. It's the only thing. Yeah. Okay. Yeah. I mean, I get this logic part, but it's just it doesn't make sense why this has the exact correct running total when the dictionaries, when we had all the combinations, we still had to calculate stuff from it. Yeah, why does this know exactly and the other one doesn't?
I guess it's not dictionary. You just want num. It will be the whole combination. So.
Okay. Wait, why? How does this transition here? So next one is one. And when it gets to here, I need to print something else. Okay, I need to print.
This is the code. Okay. Okay, let me send you. You can copy it over, I guess.
Right.
And if you print that, or if you run that, you should be able to see what the hell's going on.
Sure. What is I? Oh, that's... Yeah, I got it. I just don't want to click on it yet. I'm gonna end stream before I click on it. Wait, what is this? This is 2. Okay, so so when you transition to index 2, increased by 1, and then now
So I what's going on. So that's why the code that I sent you is actually telling you exactly what's happening.
Yeah, that's fine.